Welcome to all. Myself Vijay, Department of Artificial Intelligence and Data Science, E-Road Sengundar Engineering College. Today I am going to discuss the topic about bioamplifiers. Bioamplifiers are also called as biopotential amplifiers. It is used for designing the processing of bioelectric signals because they are low amplitude and low frequency. What are the content we're going to see on this topic? What is biopotential amplifier? What are the basic requirements, its types and working principle, applications and advantages? What is biopotential amplifier? The amplifiers are integral part of electronic device and modern instrumentation. It is used to measuring biopotential. Because the biopotential signals have low amplitude, so we have to increase the signal strength. For that we use the biopotential amplifier. Bioelectric signals are generally low amplitude and low frequency. So the amplifier designed for processing this type of biopotential signal is called as the biopotential amplifiers. The output is of the biopotential amplifier is to analyze and record the ECG, EMG and other bioelectric waveforms. The amplifier provides high impedance and high CMRR and therefore it minimizes the loading effect. CMRR is nothing but common mode rejection ratio. Diagram for the biopotential measurement. Here in this diagram, the red dot is indicate the electrodes placed on the human body, and the electrodes are connected with the triangular symbol. The triangular symbol is nothing but an operational amplifier. Here the operational amplifier, it acts as the biopotential amplifier. Next we are going to see what are the basic requirements for the biopotential amplifier. Biopotential amplifier should have high input impedance in the range of 2 MΩ to 10 MΩ and greater impedance value and low distortion of the signal. Every bioamplifier must contain isolation and protection circuit for protect the human body from the electrical shock like that. The output impedance should be low to drive the external load with a minimum distortion. The signals are recorded by using the bipolar electrodes that are symmetrically allocated. CMRR is nothing but a common mode rejection ratio must be high to avoid the interference from the common mode signals. The ideal bioamplifier should be free from the noise and distortion. Then only we get the confident output. The constant gain must be maintained throughout the entire bandwidth. What are the types of biopotential amplifier? There are different types of biopotential amplifier. There are differential amplifier, operational amplifier, instrumentation amplifier, chopper amplifier and isolation amplifier. Now we are going to see differential amplifier. Differential amplifier is to amplify the difference between the two voltage applied input signals. There are different types of circuit used for the differential amplifier, which is designed by using the transistors or operational amplifiers. The transistors may be used as the field effect transistor or BJT, bipolar junction transistors. This is the diagram for the circuit diagram for the differential amplifier. In this Q1, Q2 are transistors. The two inputs are connected with this Q1, Q2. We get the output from the collector of Q1 and Q2. So V0 is nothing but a difference between the V1 and V2. The next we are going to see about the operational amplifier. The operational amplifier is used to perform the mathematical functions like addition, subtraction between the two input signals. They are multi-stage amplifier. They are available in the form of integrated circuit. Mostly the operational amplifier used in integrated circuit is IC741. This is the schematic symbol of the IC741 operational amplifiers. Here there are two inputs The inverting input is called as the minus input, non-inverting input is called as the plus input, and we get the output. This output is nothing but a difference between this inverting and non-inverting input. Here, the operational amplifier is operated at the dual power supply. So we have to give the two supply voltages plus VSS and minus VSS. This is the IC diagram for the operational amplifier. It is a 8-pin diagrams. So in this, the first pin is offset, 7 pin, second pin is inverting input, third is non-inverting input, fourth is minus VSS, and fifth is offset, and sixth is output, and the seventh is plus VSS, and eighth is not used, that means NC, no connection. So this is the inverting amplifier by using the operational amplifier. This is the operation diagram. In this diagram, we have to give the input at the R1 terminal, and R2 is connected as a feedback between the input and output. So when applying the Kirchhoff's current law between the R1 and R2, center of the R1 R2, we get the I1 plus I2. It's nothing but 0, which means I1 is equal to I2, the entering current equal to leaving current. So we how to get the I1? It's nothing but a total input current divided by R1 plus I2 is nothing but a V out divided by R2 equal to 0. If solving this equation, we get V out by Vn equal to R2 by R1. So the V out is depending on the R2 by R1. So if we are changing the value of R2 by R1, we have to change the output of the inverting amplifier. So the minus sign indicate the input and output are 180 degree out of phase, which means we have to give the positive input, we get the negative output. If we are giving the negative input, we get the positive output of the inputs signals at the output. So that is indicated by that minus sign. The next non-inverting amplifier by using the operational amplifier. This is the diagram for the non-inverting amplifier. In this, we have to give the input to the non-inverting terminal, which is placed on the nearby RG. So the remaining RS and RF is connected with the inverting terminal. Here the RF is used as the feedback resistor between the input and the output. So again we have to apply this Kirchhoff's current law. At the between the RS and RF, we get the output as V out equal to 1 plus RF by Rin into Vn. So here the output is depends on the RF and the Rin. So feedback resistor and the input resistor. If you change, so we can change the RF and Rin. We have to change the output of the non-inverting amplifier. Here there is a no minus sign, so the input signal is in phase with the output signal. The next we are going to see instrumentation amplifier. It consists of 3 amplifiers in the circuit. The input of the amplifier is output from the transducer. A non-inverting amplifier is connected to each of the input of the differential amplifier. The non-inverting amplifier together form input of the instrumentation amplifier. The instrumentation amplifier mainly used for the increase the very low amplitude signals, because the transducer have very low microvolt signals at the output. So that signal is amplified by using this instrumentation amplifier. Mainly it is used for the medical applications. This is the circuit diagram for the instrumentation amplifier by using the operational amplifier, because the diagram, the triangular symbol shows the operational amplifier. Here we are using 3 operational amplifiers. The third amplifiers is called as the differential amplifier, because it is used to provide the output between the two input signal. The difference between these two input signals form the output. V1, V2 are inputs to operational amplifier 1 and 2 respectively. Next we are going to see the chopper amplifier. Noise and drift are two major issues encountered when recording the biopotential signals. So the noise is caused by movement of patient or due to recording devices. A DC amplifier hits a sudden peak in the output when the input is 0. So these are the main problem occur when recording the bioelectric signal. So we have to avoid this to protect the human body from the any damage. For that we are using the chopper amplifier. The chopper amplifier samples the problem of drift in the DC amplifiers. This is the circuit diagram for the chopper amplifier circuit. What are the types of chopper amplifier? Mechanical and non-mechanical chopper amplifier. The chopper amplifier convert DC or low frequency signal into high frequency signal. An AC amplifier amplifies the modulated high frequency signals. The amplified signal is modulated and filtered to obtain the low frequency or DC signals. This is the circuit diagram for the mechanical chopper amplifier. So mechanical chopper amplifier is operated by using the S1. S1 is here act as the switch. So manually we have to operate the S1 switch for hitting the output of this chopper amplifier. So it is called as the mechanical chopper amplifier. From the figure, chopper S1 acts as electromagnetically operated switch or relay. A is the AC amplifier that has input terminal and ground terminal. Q acts as reference term. Chopper acts as a switch and it connects the amplifier input terminal alternately to reference terminal. Consider the S1 is closed at this position. The amplifier input terminal connect to Q1. So the entire circuit is short circuited, so the input voltage is 0. If the S1 is open, the AC amplifier start recovering the signal from the P terminal. So the input has alternating voltage between the 0 and input voltage. At this stage, the conversion of DC signal to square wave pulse occur when amplification. The diode D rectifies the chopped signals. After rectification, the rectified signals filtered and amplified. At the output terminal M and N, the amplified DC output signals is obtained. The chopping or sampling rate determines the chopper response time. The chopper response time is nothing but M, the time between the input and the output. This diagram shows the non-mechanical chopper amplifier. Here there is no relay or switch, so no need of mechanically operated any kind of circuits. The circuit is operated itself. For that, here they are using the lamp and oscillator and photodetector. So the sensor. Non-mechanical chopper uses a photodiode or photoconductors for modulation and demodulation purpose. When there is no light incident on the photodiode, no current follows through the circuit. If the light falls on the photosensor, it sends the light, and because of that the resistance becomes low and the current follow through the sensor and we get the output. This system is similar act as a switch. From the figure, an oscillator has two neon bulbs which operate on half cycles of oscillation. So PC1, PC2, PC3, PC4 are the photodiodes. Neon lamp 1 flashes light on PC1 and PC2, and neon bulb lamp 2 flashes light on the PC3 and 4. When light falls on PC1, its resistance value reduces and making the capacitor to charge. When light falls on PC3, making the input to flow through through it and there is no light on the PC1. Therefore, the light incidence on PC1, PC3 takes place alternately to generate a square wave pulse across the output capacitor. The generated square wave pulse is input for the AC amplifier. The AC amplifier is used to amplify the square wave pulse. The other two prototypes 2 and 4 are the output circuit. It recovers the DC signal and makes the capacitor fully charged to peak value of the output voltage. At the final stage, the low pass filter removes unwanted noise and ripples and we get the amplified DC signals. The next we're going to see isolation amplifier. This is also called as pre-amplifier circuit for the biopotential amplifier. Next we're going to see isolation amplifier. These are also called as pre-amplifier isolation circuit for biopotential amplifiers. It provides electrical isolation for the safety of the patient. It prevents accidental shock of the human body. This is a symbol of the isolation amplifier. Next, we are going to see different stage of biopotential amplifier with its operation. The various stages which represents biopotential amplifier is shown in the following diagram. The electrodes are placed around the patient's skin which provide the transition between the ionic flow of the currents in biological tissue and electronic flow of the current in the amplifier. The measurement of biopotential is critical and due to relative movements of electrode and tissue. It gives rise to electrode offset potential and electrode tissue impedance. Thus, the two interference signals are generated which are successfully eliminated at a stage of the amplification. The signal from the electrode pass on the pre-amplifier stage which help in the minimizing and eliminating the signals from the interference or drift or noise. High pass filter and low pass filter eliminate the interference signals like electrode half cell potentials and pre-amplifier half cell potentials. It also reduces the noise. The biosignal should not be distorted and attenuated and hence the filters are used. This is the block diagram of the different stage of the biopotential amplifier. In the isolation amplifier stage, galvanic decoupling of patient from the measuring equipment is served. It prevents galvanic current from the deteriorating signals to noise ratio and provides a safety to the patient from the electrical hazards. Hazards is nothing but a unwanted incident or unwanted noise of the signals. Transformer, optical and capacitive couplers are used in the analog isolation amplifiers to transmit the signal through the isolation barrier. The recording of biopotential in the last stage is done. What are the applications of this biopotential amplifier? Mainly they are used in medical instrumentation system such as ECG, EMG, CT scan equipment, patient hospital monitor system. They are also used in the electromyogram integrators and cardio tachometers. They are also used in biotelemetry and other devices to determine the specific health condition of the patient. What are the advantages? It is used to monitor and understand the health system and it displays the various recording method for the ECG, EMG, EOG likewise. Instrumentation amplifier give accurate testing and measurement, that's why it is mostly used for the medical applications. The biopotential amplifier very easy to use and stable. These are ideal for long-term usage. Biopotential amplifier are highly scalable. Even a small input can be amplified to greater extent at the input level. What are the disadvantages of the biopotential amplifier? There could be minor distortion or noise in the output. The system often depends on the special cables to remove the noise. Superimposition of originals is the only concern when the noise gets transmitted for the long range. Thank you.